Hi there, Mrs. Ortiz here, and we are going to work through Objective 6 of the 4th unit, which is solving quadratics using square roots. And so today's essential question is, how do we use square roots to solve quadratic equations? Before we jump into this, we're just going to do a quick review using a calculator, and hopefully by now you have a TI-30XS multi-view or a TI-36 Pro. To simplify each expression. So make sure that those calculators are in math print. In order to double check that, you're going to do, you click mode and then make sure that math print is highlighted. And if you get answers that are different than any of these answers, then your calculator probably is not in math print, because math print leaves expressions in simplest radical form, which is exactly what these instructions ask us to do right here. Okay, so if you type in root 49 into your calculator, you should get 7. Okay, if you type in root 98 in your calculator, you should get 7 root 2. And if you type in root 90 in your calculator, you should get 3 root 10. So you are going to do 4, 5, and 6 on your own in your calculator. So that was just a quick review on what simplifying a square root looks like, okay, using your calculator. So what we're going to do is we're going to solve quadratic equations using a square root. In order to take a square root, we have to take the square root of something that is being squared, okay, and that is the most important part of this entire lesson. So the first step is to isolate the squared quantity, and then you're going to square root each side of the equation. And when you do so, you're going to write a plus or minus to make sure that you account for both answers, and then solve for the variable. Okay, so let's take a look at these and that process. So the first thing that, and probably the most important part, is getting used to the idea of isolating the squared quantity. So we have to identify what is being squared, okay? So in number 7, the quantity x plus 7 is being squared, all right? So that whole thing, because the square is in the is outside of the parentheses, that whole expression x plus 7 is being squared. All right, so then because there's nothing else around it, it is isolated. Okay, so x plus 7 quantity squared is isolated. The squared quantity is by itself. So then we're going to go ahead and square root both sides. So we're going to square root this side, square root this side, and I'm going to switch to pen instead of highlighter. And when we square root a square, okay, these are inverses and they undo each other, and we end up with x plus 7 is equal to the square root of 11. But remember, because we wrote the square root, it's plus or minus root 11. Also remember that these are quadratics, right? So they're going to touch the x-axis twice, or up to 2 times. It could be once or none for real solutions. But there are 2 zeros for every quadratic. So there's our plus or minus to get our 2 answers. And then we're just going to solve for x. So we're going to subtract 7 from both sides. So x is equal to plus or minus root 11 minus 7. Okay, another way you might see that is x is equal to negative 7 plus or minus root 11. All right, and this way is a little bit better, because then you don't confuse what is in the radical and what is outside of the radical. Okay, so let's take a look at number, I'm going to let you do number 8, but first I'm going to go ahead and go to number 9, and then you can go back to number 8. So in number 9, again, we are looking to isolate the squared quantity. So let's highlight what is being squared. So x minus 5 is being squared because it's an entire quantity. And so we don't have anything else to move in order to isolate the square. All right. And so we're going to square root both sides. And when we do that, the square root of a square Those are inverses, so they cancel each other out. And so x minus 5 is equal to the square root of 1/4. Well, the square root of 1/4 is equal to the square root of 1 over the square root of 4, or you can put it in your calculator, and you will get plus or minus 1/2. And then we're going to go ahead and add 5 to both sides. Okay, and so now this plus or minus means that x is equal to plus or minus 1/2 plus 5. So that's two different answers. So 1x is equal to a positive 1/2 plus 5. Okay, or 1x, the x could be equal to a negative 1/2 plus 5. So our solutions for x are a 1/2 plus 5 is 5.5, or x equals negative 1/2 plus 5 is 4.5. So our two solutions are 5.5 or 4.5. Okay. All right, so now go ahead and go back and do number 8. And number 10 and number 11. Okay, so I'm going to pause real quick for you, let you work 10 and 11, and then I'm going to move on to number 12. So in number 12, remember that the first step is to identify what is being squared, okay? If we read number 12, it says 9p squared minus 1 equals 80. So the only thing that's being squared is the p, okay? The 9 is not being squared. If the 9 was being squared, it would be in parentheses like this. It would say 9p quantity squared, okay? And that's not the case here. So what we need to do is we need to isolate that p squared. So we're going to add 1 to both sides. So we've got 9p squared equals 81. Divide by 9 on both sides. And p squared is equal to 9. And then we'll square root both sides and get that p is equal to plus or minus 3. Okay. All right, so I would like you to try number 13 and 14. Again, make sure that you're identifying what is being squared. In number 13, it's just the x squared. Just the x is being squared there, okay? So make sure that you solve for that x squared before you take the square root. And then number 14 is similar, okay? Number 15 is a little bit different. So if we're looking for what is being squared, 4a is being squared, okay? So both the coefficient and the variable are being squared. So in order to solve this, we've got 4a quantity squared. So we've got 4a quantity squared equals 3. And so we're ready to take the square root because there's nothing to move. All right, when we take the square root of a square, they undo one another, and we're left with 4a equals plus or minus root 3. And then to solve for a, we need to divide both sides by 4. And so a is equal to plus or minus root 3 over 4. Okay. All right, let's take a look at number 16. It says, we have learned about solving quadratic equations by graphing. We do that by finding the x-intercepts if there are any, by factoring, which is only when the equation is factorable, and by square roots. Is there a time when solving by the square roots is not possible? Okay, so basically, in order to solve by a square root, what do you have to have? You have to have a square, okay? So to solve by square rooting, the equation must have a square. So the quadratic equation and not only just a square, but it also must have a, like, the variables must be squared, okay? So it must have a square, and all variables needs to be squared. So when we think about the three forms of a quadratic, we've got standard form. So an example of standard form might be like f of x equals 3x squared plus 7x minus 9, okay? And then we have vertex form, which might be like g of x. Oh goodness, sorry. Okay, let's try that again. G of x equals, let's see, 1/3 times x plus 7 quantity squared minus 2. And then one other form is intercept form, and we might have an example like h of x is equal to x plus 4 times x minus 1. Okay, now when you look at these three forms, do they have quantities that can be square rooted? So can you isolate the square and not have any other variables? So when we look at standard form, yeah, we can find the square, the number being squared, it's x. But the problem is that we also have this x right here. And so what do you do with that? Because then you're going to have a variable in your answer. Okay, so you don't want that. So this method of square rooting does not work when you have an equation in standard form. Okay, when you look at vertex form, okay, x plus 7, I wanted highlighter. So x plus 7 is being squared, and can you isolate that quantity x plus 7? Meaning, can you get rid of this 1/3 and this -2 if this g of x is a number? And the answer is yes. So you can use solving by square rooting when a quadratic is in vertex form. And then the last form, intercept form, you don't even have a square for, so you would not be able to do it then. Okay, so when we think about this, basically our equations need to be in vertex form, or we could say that square rooting does not work for standard form or intercept form. Okay, so we'll say square root, taking the square root, or square rooting, I don't like that as much, but that's okay, does not work for quadratics in standard form or intercept form. Okay, and then we need to go back and answer the essential question. So the essential question is, how do we use square roots to solve quadratic equations? And the answer to this is, okay, we isolate the quantity being squared. Then we square root both sides. And don't forget your plus or minus. And solve for the variable. Okay, so today's reflection question is, of the ways we've learned to solve quadratics, which method is your favorite? And your choices are graphing, factoring, or taking the square root. And then your second question is, I'm going to add another one here. Which of those methods, graphing, factoring, or taking the square root, will always work? So which method will always work? So of those three, graphing, factoring, and square rooting, which one will always work to tell you the solution, the real solutions of a quadratic? Okay, that's it. Have a wonderful day, and we will talk to you in the next video. Bye.